Solving radical equations. So in our first question, we have x squared plus 5x plus 5 all raised to the exponent of 5 over 2. So what we're going to try and do is solve for x. And we need to get rid of that exponent of 5 over 2 first. So we're going to raise both sides to the 2/5. And the reason why we're going to raise both sides to the 2/5 is because 5 over 2 times 2 over 5 simplifies to be 1. So essentially it eliminates the exponent on the left-hand side. So we get x squared plus 5x plus 5 is equal to 1 to the 2/5. So if we convert 1 to the 2/5 to radical form, that's the same as the 5th root of 1 squared. The 5th root of 1 is 1, 1 squared is 1. So we actually have x squared plus 5x plus 5 is equal to 1. Now in order to solve for x, because we have this quadratic, that means we need to bring everything to one side to solve. So we're going to subtract 1 from both sides. And then we're going to factor. So we're looking for numbers that multiply together to get 4 and add together to get 5. So we have x plus 4 and x plus 1. We set each parenthesis equal to 0, so we get x is equal to -4 and x is equal to -1. Now the last step is that, oh, I forgot the r on my factor. The last step is that we have to actually check our solutions. So we're going to check x is equal to -4. So see if the left side is equal to the right side. So we plug in -4. And simplify. So we end up getting 16 minus 20 plus 5 to the 5 over 2. Which is -4 plus 5 over 2, which is 1, which does equal 1. So x is equal to -4 works. Now let's check x is equal to -1. So -1 squared plus 5 times -1 plus 5, all raised to 5 over 2. So we end up getting 1 minus 5 plus 5, which is -4 plus 5, which is 1 to the 5 over 2. So that's going to work as well. So it looks like both answers work. So for this question, we actually have exponents on both sides. So what we're going to do is we are going to focus on the left-hand side and raise that to the exponent of 2/3. And that's because it's a rational exponent, so really it's a radical that we can simplify. So we end up getting x plus 18 on the left-hand side. And on the right-hand side, if I write this out, we have 3 raised to the 2/3, which is really squared. On the right hand side, we will expand this so then we can simplify. So we end up foiling. So we get x squared minus 2x minus 2x plus 4, and we still have x plus 18 on the left hand side. Now we need to solve, so that means that we have to focus on the fact that we do have an x squared, so we're going to bring everything to one side before we solve. So I'll subtract x and subtract 18 from both sides. We get x squared. We have -4x here, and then we're going to subtract another one. So -5x, and then we have 4, we're going to subtract 18, so we end up getting -14. Now that everything's on one side, we will factor. So we get x minus 7 and x plus 2. We solve each one. So x is equal to 7 and x is equal to negative 2. And then we also have to check those answers. So we can check 7 first. So 7 plus 18, 3 over 2 equals 7 minus 2 cubed. So we end up getting 25 to the 3 over 2, which is the same as the square root of 25 cubed. I'm just focusing on the left-hand side right now, which is 5 cubed, which is 125. On the right-hand side, we would get 5 cubed, which is 125. So x is equal to 7 works. We'll check x is equal to negative 2. So the left-hand side, negative 2 plus 18, so 3 over 2. And on the right-hand side, negative 2 minus 2 cubed. So we end up getting 16, 3 over 2, which is the square root of 16 cubed, which is 4 cubed. And on the right-hand side, we have negative 4 cubed. Negative 4 cubed is not the same, so that means that x minus 2 does not, x is equal to negative 2 does not work. So in the last question, we have 2 square roots. So the first thing we're going to do is separate the square roots, the radicals. So I'm going to add the root 3x to both sides. So we're left with square root of x plus 4 is equal to the square root of 3x minus 2. Then to get rid of the square root on the left-hand side, we're going to square both sides. So on the left-hand side, we get x plus 4. And on the right-hand side, we're going to just expand that binomial. And then FOIL. So when we multiply the square root of 3x times the square root of 3x, then we're multiplying something by itself. So we end up getting 3x, the outer, negative 2, square root of 3x. The inner is the same thing. And the last is plus 4. Is I'm going to collect like terms. And isolate the radical on one side. So because the radical is already on the right-hand side, I'm going to leave it on the right-hand side. So I'm going to put those together. So negative 2 and negative 2 would be negative 4, and then square root of 3x. The other terms, I'm going to subtract 4 from both sides, and I'm going to subtract 3x from both sides. So we end up getting 4 and negative 4 will cancel, and then x minus 2x. Now because they're both negative, I'm just going to divide by that negative. So we have 2x is equal to 4 square root of 3x. Now the next step, because I have a radical on the right hand side and I want to get rid of it, is I'm going to square both sides again. So we end up getting 4x squared on the left hand side, and when we square this we would get 4 squared, and we would also cancel the square root and the squared. So we end up having 16 times 3 x and 4x squared on the left hand side. Now because again we have a quadratic, we're going to bring everything to one side before we can solve. So we have 4x squared is equal to 48x. We'll subtract 48x from both sides so we can solve the quadratic. So we have 4x squared minus 48x is equal to 0. We will factor this. We're left with x minus 12 equals 0. We set each one equal to 0. And so we get two different answers, x is equal to 0 and x is equal to 12. And then we have to check them. So when I check x is equal to 12, we plug that into the left-hand side. So we get the square root of 16. Oops, I actually have to plug that in. Minus the square root of 36. 4 minus 6. So negative 2 is equal to negative 2, so that's going to work. And then we'll check x is equal to 0. So we get the square root of 4 minus square root of 0. So that's 2 is equal to negative 2, and that does not work. So that means that our final answer, is x is equal to 12.